Okay, guys, we are going to do some graphing today. So we're going to continue talking about slope and how it relates to the equation that we're going to be making. Equation that we're going to be making. That didn't make any sense. The equations that we're going to be writing, and then we'll graph our graphs from those. All right, so this is 2-7. We're going to analyze linear equations in the form of y equals mx. And remember, guys, m is slope. Slope is just how steep a line is. So that's that. Okay, so a group of college students developed a solar-powered car and entered it into a race. The car travels at a constant speed of 100 meters per 4 seconds. So if we have this 100 meters per 4 seconds, and we want to figure out how far the car travel in 1 second, basically you take this 100 meters, you divide by 4 seconds, right? And then we get, let's see, 100 divided by 4 is 25 meters per second. Okay. Very simple. We've done a lot of this. And now we're going to, sorry, my phone's displaying some photos of my younger son being very cute. So how far does the car travel in 60 seconds? Well, you know how much it travels in 1 second. That's 25. So you're just going to take 60 and multiply by 25. And this is like 60 seconds. This is 25 meters per second. And I like setting it up like this because it eliminates the variables that need to be eliminated, right? So we've got 60 times 25, which gives us 1,500 after we multiply them together. So yeah, those seconds get eliminated, and it ends up traveling 1,500 meters in 60 seconds, which is, I don't know, let's see, 45 miles per hour? Shoot, I don't know. That's pretty good. So how did we solve number 2? Well, we just took the time and we multiplied it by the distance in 1 second. By distance traveled in 1 second. Yeah, I don't know. Pretty simple. We've done a fair number of problems like this. Kind of like this exact same style where you have like the total amount, you divide by how many seconds it has or whatever, right? We've done a lot of price problems. And so that gets you down to how like your unit rate, which is basically 1 unit right there. So basically in 1 second, you go 25 meters, and then you just kind of figure out the 60 seconds and multiply them together, and you're good to go. So the idea here, right, is this 100 meters divided by 4 seconds. That right there is our slope. Right? That's how steep this line is when we graph it. Okay. Remember, we have the rise over the run. So the rise is the vertical distance on our graph, and the run is the horizontal distance on our graph. So that's kind of how it relates to these equations. So relate the constant of proportionality to slope. Constant rate of change is probably usually how I would refer to this. And the idea here is that you're going to get the same answer when you do your division every time for your slope, right? So that's how you know it's a line when you graph it. So the students in Meg's class are building a fence around the class garden. How can they use the pricing for different lengths of fencing to determine the cost for 50 feet of fencing? So we have 6 feet at $30, 15 feet at 75, and 24 feet at 120. So we got to figure out how much it's going to cost for 50 feet of fencing. And so we've already got these 3 points graphed right here. And we're going to figure out kind of the rise over run. Now it's awkward with the graph because it's, in terms of it's like in terms of 25, right? So what we're going to do right here is this point to this point is actually 75 minus 30 is 45. And then 15 minus 6 is 9. So that's your rise, that's your run. And then between these 2 points, we do something similar. You take this 120 minus 75.
It is a B day, so you're going to your B specials today. So everyone, this is Miss Bolivia. I was so
And then
excited.
24 minus 15.
Trunk or treat was amazing. Our student council helped create and support this
Oh,
fantastic
look at that.
event. There were
Same
hundreds of
numbers.
people who showed up.
So
Stephen,
constant
right out of Katy, which
proportionality.
I could not believe. Thank you for bringing your families, and I hope you had a lot of fun. It was great to see you. We had the best car winners, and two of them were from our staff. Congratulations, Mr. Milberg, with his Viking ship. He takes the honor of first prize, first place. Then congratulations to our autism team and their Jail Dragon car took second place. The third place winner went to a seventh grader's family car, Alice in Wonderland. So way to go, Renata Zubiate. That was a fantastic car too. So those were our top three winners, but we had lots of wonderful cars. Events that are coming up. November 11th is Veterans Day, and we are going to celebrate with learning more about this incredible day and honor some of our veterans. We are also going to have some guest speakers come in, so your teachers have signed up for you to learn more and have some of these guest speakers in your classroom. Also, Mr. Milbert's second grade class is collecting any extra Halloween candy to be sent out to our active military members who are deployed. This is a worthy cause of honoring our veterans with that extra candy that you don't need, and it's a great way to honor these individuals. So if you have Halloween candy that you want to donate, please send it to Mr. Milbert's class. And they will send thank you notes and send those out to those people who are deployed right now. Also coming up, our middle school will have its first dance on November 18th. I know it's a ways away, but middle schoolers keep working towards that because we would love to see you at that dance. Also, last Friday, we had our character day, and we had one class that had 96% participation, and they will receive a treat today. It was a first grade classroom. Drum roll, please. Congratulations, Mrs. Lockman's class. Way to go and dress up and show your hot pride. All right, everybody, it's Monday, so let's make it a Monday, magnificent, wonderful day. Have a wonderful day.
Okay, hopefully that made sense, guys. We get our rise of 45, our run of 9s. We take rise divided by run, 45 divided by 9 gives us 5, right? And then we can actually put this in an equation, right? Y equals mx, right? Our y value, that's kind of like the vertical numbers, and our x values are the horizontal numbers. And you basically will get the answer for your y values if you take your slope, which is 5, and you multiply it by the x, which in this case, we're looking for feet, but very specifically 50 feet. So our slope of 5 times our 50 feet that we're looking for is 5 times 50 gives us 250. That's how much it costs for 50 feet of fencing. Ta-da! So that is your linear equation right there. I think that's the first time we've really talked about that, this kind of form right here. Very important equation. We'll be talking about this a lot, actually. Okay, so then if we kind of do this one on your own, you're going to take your, we have 1 point right here at, let's see, 480. Right? And then we're putting it into this formula right here. So 80 goes here, and then 4 is right there. And then we have 3 and then 60, which we've kind of, they've already, chosen that 3, so it's 60 right there. So then we just subtract them, right? 80 minus 60 is 20 is 1. So the equation is 20 divided by 1, which is just 20. How do the equations y equals mx and y equals kx compare? Well, what's your k? I don't know. That doesn't make any sense. Weird. Because we're not talking about scale. Oh, I guess we are talking about scale factor when we talk about proportionality. We haven't actually gotten that deep into that, so I'm not going to worry about that one. But yeah, that's your equation. That's kind of how you find your slope from 2 points, right? You take your y values, you put them on top. So we have your R80 and R60 here. And you have your x values of 4 and 3, and you put those on the bottom. And you subtract them, and you're good to go. Okay. So now we have example number 2. A drone descends into a mining cave. The graph relates its distance below ground to time. Write an equation that describes the relationship. So we got to figure out our slope right here. So we have actually a lot of points that we can use. We have this one right here. That's a good one. That's 1, -250. And then we have, let's do this one, this 3 and -750. Now, I am going to use something called a slope formula right here. I think in my videos I've talked about this, but I didn't actually talk about this that much in class. Okay, it's the same exact thing, right? That y2 minus y1 is the rise, and that x2 minus x1 is your run. So that's kind of how they relate to what we've talked about before. Now we have these 2 points right here. I've got 1, -250, and 3, -750. -750. Sorry, running out of room there. And so the idea here is you're going to apply that you're going to kind of break these points apart and put them into this equation right here. Now remember, points consist of an x and a y value. The x is first, the y is second. So that's what we have, the x's and the y's. Now we have 2 points. That's where this 2 and 1 come from, right? So our second point is right here. This is our y2. And then our y1 is right here. And our x2 is here because it's our second point. That's the x value. X1 is right here because it's your first point. And then that's the x value for that point. Now you just put it into this formula. Take this -750. And we're going to subtract our y1. Now remember, you've got to carry this negative over, and the original equation is subtraction, right? This is kind of what we did right here to figure this out, right? Right, because we could do the same thing, -250 minus 750. Or sorry, this is our second point, so we'd say -750 minus -250, like by basically just like figure out the difference, right? And we put it over our x values. Our x2 is 3, and our x1 is 1, so 3 minus 1. So -750, I'm going to simplify this a little bit, right, becomes that 2 negatives becomes plus 250 over 2. Because 3 minus 1 is 2. And now this becomes -500 divided by 2. Remember, -750 plus 250. You just, you can think about it as 750 minus 250, but then the result's going to be negative because your first number is negative. Your bigger number is negative. And so that becomes -250. So that's your slope right there. And now remember, our equation that we talked about is y equals mx. So we just basically take our -250, plug in for that m value, and we're good. Okay. So it becomes y equals -250x. Just like so. And by the way, this is meters per second. So they descends at a rate of 250 meters per second. All right. Graph an equation in the form of y equals mx. A recipe for trail mix calls for 1 cup of raisins for every 2 cups of granola. Write an equation that describes the relationship between raisins and granola. So hold on one sec, guys. Okay, guys. Okay, so you've got this graph right here, which you can't see. So let's go to it. Okay. So we're going to put raisins on the y-axis and granola on the x-axis. And those y's and x's are very small. And then we'll just say 1, 2, 3, 4, 1, 2, 3, 4, and then we go up to 5. That's fine. Okay. Recipe for trail mix calls for 1 cup of raisins for every 2 cups of granola. So we basically find 2 here and go up to 1. And then we write an equation that describes the relationship between raisins and granola, and then graph the line. So that's our slope right there, right? We can do another one. We'll just kind of go over 2 more and up 1. And then got this, and I'll kind of eyeball my graph right here. So that's our line right there. So we actually did the last part of it. Now let's find our slope. We go up 1, that's our rise, and we go to the right 2, so that's our run, right? Remember, slope is rise over run. So our rise is 1, our run is 2, so that's 1/2. Now remember, our equation is in the form of y equals mx. So we just plug our slope in for that m value, and that's what you get. So y equals 1/2 x, that's our line. Fairly easy, I think. Yeah, so you're going to take this, fold it in half. This is going to go on, I don't know, 26 for me, maybe? Yeah. Uh, 2-7, analyze linear equations. Um, and we're on page 26. There you go.